We're going to start with student presentation. It turns out it's from an ASDO group of students, and the good news is I don't get to vote, so I won't. It's a pilot study for implementing CAD/CAM dentures. CAD/CAM technology you want to hear about is the rage in dentistry now, and it's looking at implementing the CAD/CAM dentures into our prosthodontic clinic. The team members are some D3 students, Kristen Castelin and Varisha Parikh, and their faculty mentor, Dr. Clark Chen. And what's great about Clark is that not only is a prosthodontist on our faculty, he's an ASDO graduate that came back to teach. So we're very honored. So let's hear it. Let's get our team number one in here. Dr. Chen, students.
You're
All
upper.
right. Upper.
Upper, yes, ma'am. Are you pulling really hard?
Mm-hmm. Yeah, she's shaking.
Come on, get that upper out.
Hope you can get sound on that video.
Get your finger up on top and pull down. No? Should I have a professional do it?
I guess.
Okay, just stay right
So
where you are.
are you telling me that you cannot get that upper out?
I cannot get the upper out.
Okay, let me see if I can try.
Did it go down better that time, or is it still stopping?
That is. Did that hurt at all or no? Did you hear the suction?
No, it didn't hurt.
It's okay.
So that's a clinical result that every dentist would dream to have, right? A patient saying that they can't get their denture out. And this could be made possible by implementing CAD/CAM technology into our digital dentistry fabrication process. Now, to really appreciate the innovation of this technology, you really got to understand how dentures were made in the conventional method. And these have been made the same way pretty much for 100 years. So we'll dive into this a little bit more. And the fabrication of this denture is split up into clinical steps where the patient's in the chair, and also in laboratory steps where the patient is gone. So we'll just get right into it. So the first step, you got to make a mold of the mouth. And we're going to fly right through this because it's not the focus of the study. But the mold of the mouth, unfortunately, isn't accurate enough to make the denture off of. And if you want to know why, you can ask some of our D4 students here, and they better let you know why. But that gets sent to the lab where you make a customized tray. With that customized tray, you bring the patient back for the second appointment where you make a more accurate mold. With that mold, what we want to do is make a denture template. This denture template is made of two materials, the acrylic, which is adapted to the tissue surface of the ridge, and also wax, which goes on top. And wax is used because it's easily adjusted. You can add or subtract very quickly. So we bring the patient back for the third appointment where we want to make some measurements and adjust the template to size. So how long do we need to make this template? So there's 4 criteria we use. One is the incisal edge position. How long do you want to make the front teeth? That's one measurement. Obviously, you want the denture to be parallel to the horizon. You want it to have a slight tilt to it to mimic your natural teeth. And you don't want the denture to push your lip too far out, but you also want to replace some of the lost structure that you have when you've lost the teeth. So once it's all to size, we can send it back to the laboratory and we can set the teeth into the template. Now, a trained lab technician can probably set these teeth in maybe an hour. If you give this to a dental student, they may be able to do it in 8. If you leave them alone, it's probably 16. So it takes a while to kind of put all the denture teeth in the right spots, okay? So teeth in, try it in the patient's mouth in the 4th clinical appointment. They like it, then we turn this wax into acrylic, and we call that processing the denture. So this is a process in which you flask or make a mold of it, you boil out the wax disappears, now you got space. You fill that space with acrylic, and that polymerizes and hardens, and then you can deliver that denture to the patient. A few things about this acrylic. One, it's through injection molding, okay? And it's made out of polymethyl methacrylate, which polymerizes and shrinks as it sets. This is usually packed at about 85 psi, and in monomer form, it has a 21% volumetric shrinkage. So those are some of the properties of the acrylic we use. We'll deliver the denture and hopefully the patient's happy. Now let's jump into the digital method, and we'll give you a little video preview. So one of the first things that you'll notice about this digital process is that we can combine two of the clinical steps. So your final molds and your measurement step can be combined into one, and we're able to do that because we don't need a stone model. As you saw in the video, we're able to digitally scan what the impression in the mouth look like. Another advantage is instead of moving teeth and wax, which the students really don't appreciate, there's a high learning curve. We can now do it with just a click of a mouse. You saw in the software there, instead of melting wax in a very technique-sensitive kind of way, you can just click and drag, and it makes it much more efficient, much more easier to learn. One of the main reasons why some students really despise dentures is all the lab work and the technical aspect that goes into it. These students nowadays are all familiar with digital software and things like that, and should be really intuitive. Another big advantage is the material in which it's made out of. So let's visit this subject here. So instead of injection molding, the denture is actually milled out. Still made out of polymethyl methacrylate, but now it's packed at 50 times what the conventional method was. And we reduce the polymerization shrinkage to basically none. So the advantage of this is there's no porosities in the denture. You don't get fungal infections. The fit of the denture is exactly what the impression is. There's no polymerization shrinkage or distortion when you break the denture out, and that's why we can get a fit like you saw with the lady in the beginning. Okay, so this just happened yesterday as an example. Patient came in, 4 years, got this denture made, one of the teeth broke off. So you can see some of the disadvantages of the conventional method.
So the goal of our pilot study would to be seeing if this is able to be implemented at ASDO and be successful in our clinic. So the first goal would be to establish patient outcomes, seeing if this works for our patients here at ASDO. We would start with 9 patients, all which have received conventional dentures made here at our clinic. They would wear a digital denture set for 2 weeks. They'd come back into the clinic and take a simple 10-question survey, just seeing if they like the denture more or less, which one lets them eat better, which one lets them speak better, which one's more comfortable. And then we'd have 2 faculty members examine the patient clinically and establish whether or not the digital denture is a good fit. Is it a good fit? Is it retentive? Is it stable? They would look at the occlusion and see how well they do bite and how well they do function. And they would look at the aesthetics, looking at the lip line, looking at the things that Dr. Chen mentioned earlier. We also want to establish if this is a good student learning experience. To do that, we would look at 3 main things. We're going to bring students in who work on these patients with the digital dentures and give them a 10-question survey and interview. We'd establish if this helped patient management. We are focused on whole person healthcare. A lot of patients take off work to come in. Lessening the amount of appointments and the time of the appointments could be life-changing for some of these people, saving them a lot of time and seeing if they like this system better. It also helps with our lab communication skills. We need to bridge the digital gap between dental students in the lab and practicing dentists in the lab. So this would help us implement new softwares and increase our lab communication as well. And finally, we want to see if this is a good learning experience. We want to determine if we're still getting the same conceptual ideas learned through the conventional method and the digital method.
So the final component would be a cost analysis between the conventional and digital dentures. Conventional dentures, this is the laboratory cost. This is just lab fabrication, totaling to about $413 per arch. For the digital denture, we're looking at about $275 per arch, a cost savings of $138. Now multiply that by 450, which is the ballpark number of arches of dentures we make at the ASDO clinic per year, and we get $62,100 in cost savings. Now, on top of that, the dentist must take into consideration chair time savings. So with the shortened processing of digital dentures, we are saving about 300 appointments. Now, assuming that the average production per appointment is $110, given that another student could be using the chair during those 300 visits, we arrive at the number of $33,000. Totaling those together, we're looking at a cost savings of $95,100 with full implementation.
Okay, so we got costs. Here's some final thoughts here as we wrap it up. Timeline. We were able to start this yesterday. We had a bunch of students go to the factory. We have all the equipment that we need to start this process. We just need your money. The big thing, and I just want to wrap this is my final thought, lab communication. As an educator, this is why I find this project to be significant, is that 2005, there's about 4,600 dentists graduating and 551 lab technicians. We fast forward 10 years, we're up to 6,000 and only 320 lab technicians. So we have less lab support. We need to graduate students that can speak the digital language, yet know the lab skills involved. I just want to finish with this. This is from the ASDO Gospel that we find on the website. To promote the delivery of optimal patient care and for the transfer of newly acquired knowledge, skills, and technology to the profession and to the community. And this is what Dr. Dillenberg speaks about when he talks to pre-dents and about our school. So help him preach the gospel.
Thank you, Greg. Let's hear it for that. What a presentation. Thank you. Okay, we have the judges have 5 minutes now for questions, clarification. So please be available. Any questions from the judges? Dr. Wendell.
Hey, great presentation. I really enjoyed it. It was really informative. I'm wondering where the machine is that does the tooling of the denture. What does that cost? Do we own it? And
Right.
did you factor that into the cost analysis?
Right, so that lab fee that we showed, $275 per arch, is what the company would charge us to help fabricate that. So we send them all our impressions materials, and that's the factory we actually visited. They're just up in Scottsdale. So they have all the milling machines there. They have the software to help design where the teeth go, and they actually send us a copy of that file where we have a viewer where we can see, oh, are the teeth in the appropriate place? So learning-wise, there's not much difference from the digital to the conventional method. It's, or the theory of it. The difference is instead of melting wax, let's say if you want to move a tooth, you just click and drag. So in terms of the learning aspect, I find that to be fairly equivalent, just a different method of doing that.
Great, thank you. Bob? I got 3 questions. Yeah, well, okay.
Sorry.
You got a minute apiece.
Okay. First of all, I think you did a great job. Very impressive. What about the time, the life cycle for the patient? How long does it take to get this new denture versus how long it took before?
Right, so we're reducing clinical steps by 1. Right. Right now, the average time I'd say to make the conventional denture is probably about 3-4 weeks with the student schedules and all that. By reducing it, we can probably get it down about 2.5. So there's time savings for the patient as well.
And what has anybody done any life cycle analysis on these new dentures? I know 2 weeks we're going to do it, but what about 2 years or 20 years? What happens to these dentures?
So I believe on their website, they've had some studies at universities that have done cyclic loading under kind of clinical situations, so soaked in water. And they found that the bond strength of the teeth there are equivalent or no significant difference to the conventional method. So.
And I'm assuming we're not the first ones to do comparative studies on old dentures versus these dentures.
Correct.
Do you have reports and studies on that?
Matthew Catadill, grad prost director at Loma Linda University, has done a study to kind of formalize this. Yeah.
Great. Thank you.
Thanks, Bob. Michael? And then we'll get to...
Have you thought through about the time and considered IRB, Institutional Review Board approval, before you can move forward with this project with actual patients?
Not yet, just because without any money, it was a lot to undertake as a precondition to apply for the grant. But certainly, that's should be on the table. Yeah.
My second question, real quick, is teaching CAD/CAM already built into the ASDO curriculum, or would this be something that would have to be added into the curriculum?
It's becoming a more important component of our education. The faculty is doing a really good job of introducing us to this technology and encouraging us to become competent in it as we might be implementing it on our own in private practice. So this would just be another step in that direction of becoming more technologically competent.
And just to add to that real quick, they have in their fixed prosthesis modules, this is the first time for anything removable, and only less than 12% of all dental schools have any removable digital component to removable.
So it's innovative in that sense.
Innovative, and not many schools are doing it full on, beginning to end, to delivery of the denture. They may only have segments.
Let's get Sean in the back, and then Sean.
What's the percentage of current private practice that would be incorporating this, the CAD/CAM mapping on a daily basis?
Right. I can't speak to an exact number. In the colleagues I've talked, there's, if I had to put an estimate on it, maybe 5 to 10% kind of early adopters. But I think the market is quickly growing, and I'm sure there's going to be some data on that. 50% of graduate programs have this technology somewhat implemented in some form or fashion.
So you would anticipate if this was seeded into the curriculum, let's assume wild success, that it would become much more, all our graduates would then have this and it would pull in the market.
Where this technology is really going to be kind of implemented widespread is with implant therapy in conjunction with dentures.
Thank you.
Fixed.
Huge.
Yeah.
Did you have a comment, Beth?
Actually, just to tag on to that question, so in relation to teaching and learning from the student perspective, is this something that's anticipated is going to replace the current method altogether? If my concern is, do they intend to go completely to this digital format and stop using the other format? And would that hinder students who might not see the new format, depending if they go to a CHC that might have that technology?
So let's have one of the students answer and I can follow up.
That's not our anticipation. We want to supplement our current learning. What I was talking about earlier, kind of drawing in the conceptual ideas and making sure that students are still getting the benefits of that from using this digital system. So that's one of our goals of the pilot study, is to kind of evaluate that and analyze it and see if we are getting that same learning experience.
And it fits into our curriculum because as of now, we have to do one essential denture and one competency denture. So right now, those are both conventional. If we were to implement this study, and assuming huge success and we implement this into our curriculum, we have a built-in system for one conventional and then potentially one digital.
And remember we split up.
Time is up, but okay, sorry. Norma, you didn't get a chance for question. You got a quick one we could sneak in?
You talked about cost savings. Is this to the school or to the patient?
To the school, yeah. I mean, we haven't factored that into the patient, but that certainly could be an option. Or toss it.
You just made me and Dr. Dillenberg cry.
That's right.
We can fund 20 years of Spark Take if we do
All
one.
right. Thank you very much. Let's hear it for this presentation. Thank you very much. Well done. All right.